Hey everyone, hope you're having a great day today. I have something a little different than normal. We are starting a new series called Private Pilot Ground School. This is going to be both for CAP members, cadets that maybe want to learn how to fly. It's going to be for folks that are learning to get their private pilot's license. They want some additional education material to help supplement their ground school, as well as anybody who is into flight simulation. They want to kind of take it up to that next level. And so our first lesson I really want to talk about today is the E6b Flight Computer. We're going to be getting into flight planning, and knowing how to use an E6b Flight Computer is really helpful. My name is Bob Roberts. I actually am an Aerospace Education Officer with Civil Air Patrol here in Greenville, South Carolina. So we talk about E6bs, we talk about really three different styles of E6b. So this is the first style. So the first style is a mechanical style, and it really has two sides. So the first side is the mechanical slide rule side, and that helps us with logarithmic functions because everything on this side is really a function of log or scale. Now the back side we call the wind side because it's used to help determine the differences in wind speeds and what those wind speeds are going to be doing to the aircraft. Use that when you want to figure out pretty much what the crosswind component is, headwind, tailwind, things of that nature. So this is the mechanical side. Even if you have a flight computer or something that actually does these calculations for you inside of the airplane, I still recommend getting a flight computer. Okay, so this is the mechanical style of that. This is made by ASA. You'll hear this say over and over again on these ground schools. I'm not sponsored by anybody. Nobody knows me. But anyway, so this is the mechanical. Now the other style that I tend to use a lot personally when I'm doing flight planning is this is a calculator version of that. This is made by Sporties. Again, no endorsements here. I really do like this. It's battery operated, so that means I like to keep this in the flight bag just in case because batteries die. And so anyways, but this does a good job because you can put in a couple things and then it just feeds itself that information when you're doing additional calculations. So it makes the flight planning a little bit easier. So definitely like this. I could be wrong. I believe this is give or take 30 bucks. I believe this is give or take 80 bucks, give or take. In the description down below, I'll put links to this stuff. I don't make any money from it, but if you want to buy it, I'll put it in the link down below. And then the last style that we'll talk about here is actually our phones. On the phone, you probably can't see it. I'll throw a zoom up. There is an app. There's an app for everything, right? So there's an app for an E6b Flight Computer. And again, I'll throw a link to this one. This is really nice because if you don't have this available, then this is good. Also, like I said, you know, this is shy of $100, I believe, and this was $10. Now the last style is going to be what you're probably going to be using today. Unless you're one of my cadets that's gone out and purchased one of these for this lesson. The rest of you can use a simulator. And so I'll have a link to that simulator down below. If you are watching this live, go ahead and click that link if you don't have a mechanical or another way of doing it. So yeah, so it's really hard to show a mechanical simulator on video. You get a lot of glare in the lights. So we're actually going to use the simulator online. So even if you have this one, I actually recommend that you go ahead and practice with this in your hand just to get used to spinning the dials. But no harm, no foul if all you've got is a simulator online. So, all right, let's go take a look at that now. All right, now we're on the computer. So go ahead and in the description down below, I'll give you a link to this media file from the University of North Dakota. They have an aerospace department there, and this is their simulator. So I want to give them credit. This has nothing to do with me. This is the University of North Dakota. And you can find a link to this down below. All right, so what you are seeing here is the slide rule guide. So if you remember correctly, right, that's this side. And so now we just have a digital version of it. So this will be much easier for us to use. And then on the website, there will be a link and you can click what says the wind side. And you'll notice that the wind side looks just like that. And you can move this around just like you would on the mechanical. All right, so on the slide rule side, you're going to notice that it basically has the disc that rotates freely around the back. And so what it does is it gives us actually 3 areas. So the first area is this outside area here. Amazingly enough, we call this the outside area. The area that's just on the edge of the inside dial that swings, we call that the middle area. Okay, and then on the inside portion, you'll notice that there's actually a couple calculations you can do. So you can do an altitude correction, you can do an airspeed calculation. So when you're flying, there's less dense air. So the speed that the airplane tells you it's going at is different actually than the true airspeed, let alone the airspeed once you take wind into account. So that's a different calculation. We're actually not going to take that into effect for today. That might be in a future video. If you actually want to see me do those calculations, show you how to do that, do me a favor, leave that in the description down below. And if I see folks that want to see that, I'll do a separate video on that. Okay, so you're going to see me looking away here because I look at the screen a little bit instead of the camera. But the first thing you want to look at as you move this around is this area right here. And you'll see a little bug, a little triangle, and you'll see the 60 underneath, and you'll see it's a rate. And so anytime we're doing a calculation, we set this as the rate. So for instance, if I was doing a fuel calculation and I wanted that to be 15 gallons per hour, I would put that bug on the 15, and that would make it 15 gallons per hour. And again, you see the 60 down here below. That's because it's per hour. We're used to doing things per hour. So another thing, if we were traveling, let's say we had a really slow airplane and the airplane was going 90 miles per hour, we would take that rate and we would put the rate on the 90 for 90 miles per hour. Okay, the other thing you'll notice too is that, when we get this rate, when it goes all the way to here, we start at 10, right? And then we go to 11, 12. Notice the distance between those, right? So we actually have 10, 11, 12, 13, 14, 15, all the way to 11. But then you're going to notice when you get to 15 that you don't have the little hash marks, right? Everything starts to get smaller. And so now you're going to go 15, 15.2, 15.4, 15.6, 15.8, 16, right? And you're going to do that till you get to 25, right? And now it gets even smaller. So it's going to go 25, 26, 27, 28, 29, 30, right? And you're going to do that again. You're going to get smaller and smaller and smaller. Now, when you get back up to the top here, you don't start back at 10. What you're going to do is you'll notice there is no hundreds, there's no thousands, there's no 10,000s. And so what you do is you just basically add on, you move the decimal place in your head basically. And so when you go to 10, you're going to go 20, 30, 40, 50, 60, 70, 80, 90. And then in your head, you're not going to go back to 10, you're going to go to 100. And then you're going to do the same thing. Then you go 110, 120, 130, 300, 400, 500, 600, 700, 800, 900. And again, we're going to move the decimal place on us. So we're not going to go back to 100, right? We're going to go from 900 to 1,000, okay? So hopefully that makes sense. The same is also true for the middle ring, okay? So where we have the 40, this 50, right? You have to kind of do the calculations in your head to say, okay, I have to add a 0, right? Or I have to take a 0 away. And so really what you have to do is it has to make sense, right? Okay, so let's take an example, right? So if you're going in a Cessna and it's 182 maybe, and say you're going 150 knots, it has to make sense, right? So if you had to go 450 nautical miles away, then you would look down here. We're going to show you how to do this calculation in a second, but you would look at the 45 because 450, right? So there's no 450. So you would look at the 45 and you would see that it's showing you 18, but we had to add a 0 here, right? So we're adding a 0 on the 18. And so the 450 knots would take you 180 minutes. And oh, look at that. That's 3 hours. So that's how we do the zeros and the tens, hundreds, and thousands on the computer. Okay, so the next thing we are going to do is we are going to do some time en route calculations. Okay, so we are going to, for our first calculation we are going to do the calculation for how long is it going to get there, right? So that's the big question everybody always wants to know. All right, if you got kids in the back, right, you got a husband or wife, they're nagging you on the side of your shoulder saying, honey, how long till we get there, right? So what you can do is if you know how fast you're going, let's say we were going, well, we said 150 knots before, so let's stick to that. So we have 150 knots. So we're going to take our rate, we're going to take that little bug, and we're going to move that to the 150, right? There's no zeros, so we're going to move it to 15, right? And then we're going to say we have to go 245 knots. We're going to make this a little bit more interesting. So anytime that you're looking at speed or distance, you're looking at the outside scale. All right. So we said 245. So if we go down here, I think I can actually zoom this in. So we're going to go 245. And that's going to tell us that we have, give or take, about an hour and 37. About, what was this, 90, 95 minutes. 96, 97, 98. So it's about halfway between 97 and 98. So let's just call it 98. It's always better to tell somebody that it's going to take less time, unless you're doing calculations for fuel. But if you have the kids in the background, always lie to them. Tell them it's less. So, all right, so you have 97 knots. So that is one example. So let's do one more of those. So let's say you're in a super fast airplane, and let's say you're going... we'll make it easier for ourselves. Let's say you're going 200 knots, and let's say that you are going we'll say 500 nautical miles away. So if you're going 200 knots, we're going to go to 500, right, which is here. And that would be 150, right? We're adding zeros to the 20. We're adding a 0 to the 550, making that 500. So we're going to add a 0 to the 15. And so that'll be 150. And so that 150 equals out to 2.5 hours. So if you were going 20 or 200, if you're going 20, you're probably going to fall out of the sky. But if you're going 200 knots and 500 nautical miles, that's going to be 2.5 hours. So that is just two examples for how long it's going to take there. Okay, so let's do a calculation to see how fast we have to go in order to get to someplace on time. Sometimes we're in the air and we're just, we can slow the airplane down because we want to save on fuel. And other times we got to get someplace, right? So let's say where we're going is 70 nautical miles away. So again, the speed and the distance is in this outer scale. And so we have the 70 right here. And let's say I need to get there in... let's say 45 minutes, right? So let's take the 45, right? 45 in the middle, and we're going to put that on the 70, right? Now we have 70 nautical miles away, and we have to be there in 45 minutes. Your time is on the middle scale. Now let's go take a look for this bug, right? So let's zoom out. And we'll zoom up and we'll move it up. All right. And so we'll see on the bug here that we have to be going 91, 92, 93, just a little over 93 knots. And if we go 93 knots, that will get us there. And that makes sense to us, right? So again, always when you're doing these calculations, try to do a little mental thing in your head like, this number I get actually makes sense, right? So if it told me that I had to go 12 knots, right? It wouldn't make sense. I wouldn't get there in time. So anyways, so that's one calculation. So let's try another example of that. And let's take a look at, let's say I had to go 500 nautical miles. And let's say I had to get there in, let's say 3 hours. So we're going to go miles, which is over here. And then let's say I had to get there in 3 hours. So we're going to take our 180 minutes or 3 hours. We're going to line that up. Now we're going to take a look for our bug. And our bug is going to say that we have to go 16, 16.2, 16.4, 16.6, little after 16.6. Let's call it 167. So we have to go not 16.7, we have to go 167. So we have to go 167 knots in order to get to someplace that's 500 nautical miles away in 3 hours. And again, if we do the mental check, that kind of makes sense. So that's just two examples. So our next one we're going to do is we're going to determine how much fuel. So we're going to do two different fuel calculations. So the first we're going to do is how much time do we have with the amount of fuel we have. And the second one is how much fuel do I need? So there's nothing really more important to general aviation pilots typically, or any pilot really, unless you're flying a glider, to how much fuel you have and when you're going to run out. Okay, so as we mentioned before, anytime we want to do calculation this side, we have to set a rate, right? Or the rate bug is going to tell us what the rate is per hour. Okay, so let's do our first of the fuel calculations. Now, when you start off doing fuel calculations, you have to know how fast you're going and how long you're going to take to get there. Because then you can do a really easy calculation, multiply that by how much fast you're burning fuel. All right, so let's say we were going 125 knots. So if we take this and we turn that bug to 12.5, right? We're gonna add the 0, move the decimal place, so 125. Okay, so now that we have the 125 knots, let's say we're going to fly for 4.5 hours. So if we look at 4.5, that'll tell us that it's 550, 560. We're not quite to 570, and I think we're just shy of 565. So let's call that 564 nautical miles. So we know that if we're going 125 knots and we're going at so if we know that we're going 125 knots and we're going to fly for 4.5 hours, then let's call it 564 nautical miles we're going to travel. So now what we want to do is you want to say how much fuel we're using. Okay, so now that we have that, let's go ahead and say that we're flying here in, we'll go back to my Cessna 182. Let's say I'm getting 14 gallons per hour. So if I take this rate and I move that to 14 gallons per hour, we actually already know, based on the initial, that we're going to be flying for 4.5 hours. So we can go back now to 4.5, and we'll see that we're using 60, 61, 62, 63, give or take, 63 gallons of fuel. So that's how you do a fuel calculation. Okay, these are super simple, so let's just go ahead and do one more. Let's say you're in something that's sucking a little bit more gas. Let's say you've got a twin engine, and let's say you're going to burn, 29 gallons per hour. So we're going to put the rate bug on 29, and let's say you have a long flight, so you're going to go 5 hours. So if we go 5 hours, that would put us a little bit past 14.5, and so let's call that 14.55, 14.5 and a half. So, but we also know that that doesn't make sense, right? We're not going to burn 14 gallons in 5 hours, on something that's burning that much fuel. So we have to move our decimal place. So that knows that they're going to be going 145.5 gallons. So 145.5, make a little note there myself. And so that's how much fuel you would use. Again, you got to use the common sense. If I'm burning, 29 gallons per hour, 14.5 gallons isn't going to keep me in the air for 5 hours, right? That wouldn't make sense. But 145 gallons, 146 gallons, that does make sense. So that is how we are going to do our fuel endurance. Okay, so the other fuel calculation we're going to do today is how much time do I have, right? So how much time do I have before the engine stops working? So let's say again, I'm going to go back to my Cessna, and let's say I've got that thing kind of throttled up. Let's say I'm doing 14 gallons per hour, and let's say I have 88 gallons on board. So my Cessna does carry 88. So if we look at the outer scale now with the rate bug at 14, and we go to the outside here, we go 88, and the 88 would say about 6 hours, that's 6.5, that's 620, that's 610. So give or take 6 hours and 15 minutes. So that's pretty good. So if I've got it not leaned and I'm cruising pretty good, I can, before my tanks go dry, I've got about 6 hours and 15 minutes. So that's how we're going to do a calculation to see how long we can fly for. This is actually important. So like if you're carrying more people, you don't always fly with more fuel, right? So I'm a larger individual. I am 6'7", and I am 280 pounds. And so if I have a couple people in the airplane, and if it's a hot day out, I can't have 88 gallons of fuel in the wing. So I know that if I'm going to fly at, say, 12 gallons per hour, I'm going to lean it out. It might go a little slower. And I want to take people up flying, let's say for 2 hours. I can go down here to the 2-hour mark, and that's right around, well, actually that makes sense, right? The 224 gallons. So I need 24 gallons. And then if I add, say, an hour and a half to be on the safe side, because I always like having an extra hour and a half of fuel in the wing just in case, that tells me then that I would need to have, give or take, about 43 gallons in the wing. And so 43 is actually about half of what the tank holds. And, fuel weighs about 6 gallons per pound. And so 46, so that I would save about 240 pounds of weight in the wing. So that gives me extra weight that I can carry inside the airplane. So that's how we do the fuel calculations. Okay, the next one that we're going to be doing is the conversion between nautical and statute miles. So if depending on the type of information you're looking at and you're trying to calculate, some maps and some flight planning tools will go back and forth between nautical miles. Usually if you're in the airplane, you're talking nautical miles. And usually if you're on a map, you're talking statute miles. So they are not the same. And so what you want to do is you want to take a look at this portion of your flight computer. And you'll see here it says naut for nautical. And here you'll see it says stat for statute miles. And so if you're going back and forth, so let's say if you have 40 nautical miles, you'll put 40 under the nautical miles. And then if you look at the statute, you'll see that the statute says 45, 46. So 40 nautical miles is 46 statute miles. Let's do one more of those. Let's say you have 300 nautical miles. So you'll put the 30, and then, 30 would be over here, not the time. All right, so you have your 30 nautical miles. And then over here, you would read statute miles, which would be about 345, 346. And now let's go the other way. Let's say you had 500 statute miles you had to fly. So you put 500 under the statute ring. I always try to be really, really close. And then if I go back down to the nautical miles, that'll tell me I'm right on the bug. So that's 40, 41, 42, 43, 43 and a half. So 43 and a half, we have the zeros, so 435. So 500 statute miles would be 435 nautical miles. Now, I'm just out of curiosity. I want to throw 100 on nautical miles, and because then you'll see the conversion. So the actual conversion is 1.15. So you'll look here at the nautical miles, you'll see it's 10. And if you look up statute miles, you'll see it's just a little tiny bit over the halfway mark between 11 and 12. So we're going to call that 115. And so, yeah, so you're actually, whenever you're doing a calculation from nautical to statute, I have always just learned to multiply that number by 0.15. And so 1.15. And so, but if you have the flight computer, you have this nautical and the statute right here. And so you can just fling it around, because sometimes it's not easy to do. Let's say you have 42. It's a little more difficult to do, say, 42 in your head, multiplying it. So, but now here you can go 42, and you're right around 48 statute miles. So, yep. So that's how you convert between nautical and statute miles. Okay, so that is the slide rule side of the E6b Flight Computer. So let's go ahead and take a look at the wind side. Now the wind side, this looks crazy, right? So this is something that probably looks really, daunting to you because it's so busy. But I'll tell you right now, it's actually really not. So the important part here is that when you're using the wind side of a flight computer, you're going to be making a mark on this transparent window. Now, when you make a mark, you want to make sure that you're not using a real pen. You don't want to use a permanent marker. You don't want to use a pencil, because then you're just going to be leaving a permanent mark on this transparent film. And then it's just going to make it messy. And then, within a couple of flights, if you do that a few times, you're going to end up throwing this out. So there's no reason to waste $30, every couple times that you're flying. So which I always use, I use a wet erase marker. I know some people use a dry erase marker, so this way they don't accidentally use a wet erase on something else. But I do recommend using a wet erase marker. So anyways, now going back to, let's see, I'll put this over here. Okay, so let's take a look now at how we're going to do our ground speed and true heading calculations using the wind side of the calculator. So the first thing we want to do is we want to put the wind direction under true index. So let's say we get air traffic control. Air traffic control says that the wind is at 320, and let's say it is 10 knots. So let's go ahead and we put 320 under the true index. And I like to put the actual bug, this grommet here, this opening in the middle, I like to put that on 100 just to make it easier. So let's say we said 10 knots. So we'll say 100 and then we add 10. So we'll put our dot around, see if I can get that exact. Hang on. That right there. Okay. All right. So we can always zoom into on the simulator. So, all right. So now we have that, but now we want to go true course. Now true course is the actual line. If you're going from point A to point B, the direction from point A to point B is your true course, right? So let's say if you're in a boat, if the water was going this way, the nose of the boat might actually be turned down, right, into the direction that the water is coming from, because that's going to push the boat. You have to go from point A to point B. If the water's going this way, you'd have to turn the nose, and that would keep even your direction that your boat is moving is this direction, even though the nose is pointed, down into the direction of the water. Exactly the same principle in an airplane. So, if you have the wind coming this way, you have to get from point A to point B, you're going to have to turn your nose into the wind a little bit, and that'll keep the track over the ground, your true course over the ground, it'll keep it from point A to point B. All right. So what we want to do now is we want to say, okay, we're 320. And let's say we'll make it easier on ourselves. Let's say we need to do a true course from point A to point B, and that was at 290 degrees. So we'll notice that our dot moved with us. So let's zoom in here. Okay, so now what I'm going to do is I'm going to take that dot, or that mark that we made on the transparent, and I'm going to move that to how fast the airplane is traveling in the air. So let's say I'm flying a 182, and I've got kind of like going really fast. And so we're going to move that dot. We're going to say 150 knots. I'm going 150 knots. So the next thing I need to do is I have to figure out what angle I need to turn into the wind. And we do that by these scales. So you'll see the 10 degrees, the 5 degrees. This would be 0 degrees. Then 5 degrees, 10 degrees, 15 degrees, 20 degrees is over here. And so what you'll see is that dot, if we look at that, this is 0 to 5. So those are 1, 2. I need to turn 2 degrees and to the right. So if I was traveling, let's see here. So if I'm traveling 290 degrees, my true course, I need to turn the nose of the airplane to 292 degrees. Okay, so not much, very slight calculation. Now, this is a wind that's coming almost directly at me. So even though I'm going 150 knots, I know I'm going to be going slower. So if we now take a look at that bug, that grommet is sitting right about 141. And so that's how fast I'm actually going over the ground. And so I would be going true course of, I can get this on here. So my true course would be 290. My actual heading of my aircraft, where the nose is pointed, would be 292 degrees. And I wouldn't be getting my 150 knots true airspeed. I would be getting 141 knots true airspeed. All right, so let's do another one of these. Again, the 4 things I need to know where the wind's coming from. I need to know the speed of that wind. I need to know the true course by point A to point B course. And I need to know how fast I'm going. I need to know those 4 things. So let's go ahead and do this again. Let's say the wind is coming from 200 degrees. Let's make it a little faster this time. Let's say we set our bug to 100. And let's say it's a 40 knot wind. Let's say we're up in the air and we got a 40 knot wind. All right. Now let's say we have to go, I want to do something on the backside here. So let's say our point A to point B is 55 degrees. So 55 degrees. So now we'll notice that the bug is behind us. So now let's go ahead and let's put this bug how fast we're going. And so let's say we'll stick with our Cessna. So we'll move that bug up to 150. right there. And this is telling us two things now. One, the dot is behind us. It's behind this grommet. So that means it's a tailwind. We love these tailwinds, right? So, and it's also off to the right, right? And so here's the 5 degrees, and then here's the 10 degrees. So we have 5, 6, 7, 8, almost 9, right? So that tells us that I'm going to be turning the aircraft's heading nose about 9 degrees to the right. All right, so now we're going to take that dot. We're going to put it on the 150 knots here. That's the speed that our true airspeed in the air mass that we're going in. And then we're going to look up for the grommet. So the grommet now says, let's say give or take 151, slightly faster than 151. So that's nice. That gives us a nice little tailwind there. So we have to push into the wind, make a direct correction of about 8.5, 9 degrees to the right. And then it's going to actually push us along, and we're going to be getting about 181 knots ground speed. So that's actually pretty nice. It's always nice when the air is pushing you along rather than pushing against. Okay, so let me tell you why this is actually really important to actually know this in the air. And the reason why is, with our current flight computers, so like with a ForeFlight, it gives us all this information, right? You can get winds, it calculates everything. But let's go back, right? Not all that long ago, about 10 years ago, 10, 15 years ago. These really expensive glass cockpits, they weren't in a lot of places, right? And even today, you might buy, your first airplane may not be a very expensive airplane. Your only airplane you may ever buy may not be a very expensive airplane. They may not have all these fancy computers. And let's say you don't have ForeFlight in the computer, you don't have an iPad or your phone set up with ForeFlight, and it's giving you all this information, it's doing these calculations for you. And, one time I flew from Rochester, New York to Lake Placid, New York, which is in the mountains. So, and, you kind of had to fly, from west to east. And when we got to Lake Placid, it was really windy. We got there pretty fast. And I had gotten the winds and I did all my calculations. And we spent the day in Lake Placid doing some climbing. Well, when we came back, we just hopped in the airplane. It was starting to get really windy, and I made a mistake. I made a rookie pilot mistake. Horrible me. I had a full fuel tank, so I wasn't worried about how much time it would take me to get back. It's not that long to get from Rochester to Lake Placid. And so I knew I had, 6 hours of fuel on the airplane, and it's, give or take an hour and a half flight. So I just said it was getting really windy, and I wanted to get off the ground before it got any worse. So we just jumped back in the airplane. We took off. The takeoff was actually pretty interesting. Another story for another day about making sure that you have correct wind correction while you're doing takeoffs and taxi. But anyway, so we take off, we get up into the air, and it took us forever. I don't remember the exact time, but I'm telling you, it was more than 3 hours. We more than doubled the amount of time it took us to get back. And literally you could watch the cars on the ground, and they were faster than us. This is the 172, so it's not all that fast. And I had wished that I had actually tracked the calculation of the wind, because that would have done a really good job to tell us my ground speed. I knew how fast I was going in the air, but I didn't know how that related to the ground speed. Now, we were able to do some calculations based on pilotage. I knew that it took me a certain amount of time to go from point A to point B, and I had to go to point C. So I could just do a calculation and go, okay, this took me this long, so this is going to take me that much longer. But if I had actually used my E6b in flight, then I would have been able to figure out exactly how long. And man, those last hour and a half, if you're expecting an hour and a half flight and it's taking you 3 hours, that last hour and a half takes forever. So anyways, so it's really good reason to get in the habit of using this. Again, that was a rookie mistake for me. So anyways, that is it. All right. So there's really 3 times you should really be using your E6b, right? It's really going to be when you're doing your flight planning phase. It's going to be when you're doing your en route phase, and it's going to be when you're doing your landing phase, right? So your flight planning, right? So pick a point. You can do this. You can practice this. Pick a point on a map from point A to point B, right? And then do your flight planning. How would you get there? Fill out your flight plan, and then, figure out what are the winds aloft along that direction, along that route. And then go ahead and use this and actually put in your estimated heading, right? So which direction your nose is going to be pointed in to get you your true course. and then you can figure out how long it's going to take you there based on the crosswind component and the headwind and tailwind component. So that's your flight planning en route phase. If you're using a flight simulator, doing it for real, you can, how long is it actually going to, when you're in the air, you might have to adjust your calculations based on the fact that your winds might be different than what they were forecast. And then lastly, on your landing phase. So it's really important, especially if you're in a smaller airplane, you may only have a 15 knot crosswind, or you might be a new pilot. You may not be comfortable flying even close to what the airplane can do, and you shouldn't, frankly. Yeah, and then so for the landing phase, you're going to know, unless it's an unmonitored airport, it doesn't have some type of weather monitoring, on the airport, you're going to know how fast the wind is going and what direction it's coming from. And so that'll tell you how much of a crosswind, how much side to side that wind is going to push you. I'll also tell you how much of a wind's going to push you on your nose. Now, you don't ever want to land with the wind, right? Because it's going to make your wheels touch down a lot faster. So you always want to land into the wind as much as possible. All right, so what you're going to do is, for the crosswind components, you're not going to see it on that the online simulator, but on your real flight computer, your mechanical one, there's actually a graph down here, and the graph is going to give you your crosswind components. So you'll basically line up how fast and then the direction of the wind as it relates to the runway you're using. So if you're going to be landing a runway 12, so that's 120 degrees. If the wind is from 150, that would be a 30 degree crosswind. So you would look at 30 degrees, and let's say it's a 10 knot crosswind. You would go 30 degrees and you would go down 10 knots, and it will tell you how many knots of a headwind you're going to have, and then it'll tell you how many knots are pushing you from the side. Airplanes have a limit of how many knots a crosswind component that they can land on, as well as you as a pilot. If you're a new pilot, if you're watching this, you may be a new pilot, you might be somebody who wants to fly in the future. Just because that airplane says it can do a 15 knot crosswind doesn't mean you can do a 15 knot crosswind. So definitely make sure that when you're first flying that you want to get as into the wind as possible. If you have a heavy crosswind that you are not comfortable with, don't become a statistic and try to land on something because you think to yourself, well, hey, I'm a great pilot. I just got my pilot's license, so I must know what I'm doing. And the airplane says it can land with this 15 knot crosswind, so I'm going to do it. And then you find yourself getting blown off the side of the runway because you don't have the experience yet to properly use your rudder and aileron to correct for the higher crosswind components. So definitely make sure you have a safe margin. Don't push yourself, especially when you're first starting. All right, well, that's it for today's lesson. I hope that you learned something. Like I mentioned before, going down into the description down below, I'll put a link to all of these supplies. Also, I'm going to put some additional exercises as well as an answer key, so this way you can do a couple more practice sessions. I really do recommend also, going into Flight Simulator, try actually doing some planning on your own, especially if you're going to be a general aviation pilot. Best way to do this isn't to try to figure this out in the cockpit where you're paying $150 an hour. On the Hobbs time with an instructor and the airplane. Best time to figure this out is when it's free, when you're sitting at your desk and it's free. Definitely a good way to save some money and then focus your flight training. So anyways, thanks everybody for joining, and we will talk to you real soon. If you did like this video, do me a favor, the whole YouTube thing, please hit like, subscribe. It really does actually help us. It helps the algorithm to find us. The more people hit the like button, the more people hit subscribe. If you want to see any additional content, lessons that you're interested in, go ahead and put those down into the comment section down below. And as of right now, I am super small channel, so I'm responding to everybody. So if you've got something you want to see in the future, there's a pretty good chance if I see a comment saying, hey, I'd like to see a video on ABC, I'm probably going to make the video on ABC for you. So if that's it, hope everybody's a great day. We'll talk to you later. Bye-bye. Hey, I hope you've enjoyed that video. If you did, please do me a favor, hit that like button, hit the subscribe button if you want to see more content. Up here on the left-hand side, you're going to see another video from our this playlist. And if you click down here, you're going to see another video on our channel. Hope you guys all have a great day. We'll see you soon. Bye-bye.